Now in algebra we use different types of numbers, and there's actually a lot of terminology associated with algebra. Now we just want to cover that before we actually make a start. I've got here real numbers written out. Now real numbers are all numbers you could possibly think of. Now what is called a subset of real numbers is the counting numbers. They're the ones we count with. 1, 2, 3, 4. We can all do that, of course. But now we come to this term whole numbers. Now whole numbers in algebra, you add the 0 to the set of counting numbers. You can also come up with a set of integers, and then you've got these negative numbers here, the -3, the -2. Those are the numbers you find on a number line. Then we move on to rational numbers, numbers that can be expressed as fractions, and you see lots of examples there, 1 1/3, -0.337, etc. And finally, we can have what are called irrational numbers, and they are not possible to be expressed as fractions. Typical examples are the square root of 2, the cube root of 65, etc. Now these numbers are all related to each other, and the following diagram illustrates that very, very clearly. Let's have a look. We've got, first of all, the real numbers that can be split into irrational and rational numbers. Then we work with fractions and integers, so it can be split in fractions and integers. And then finally into negative integers and whole numbers. You could get a few problems with these type of numbers, and I've got some here. For instance, you might be asked to find out of this set which are integers. And then you look at it and you say, look, all of them are integers except this 0.5, because you can't have an integer that is a half, and you can't have root 7. But root 9 is, because the square root of 9 is actually 3. So here are the so-called integers listed out of this set. We go to the rational numbers. Well, everything is rational, but not the square root of 7, because the square root of 7 is, well, 2 point and then all sorts of decimal places at the end. Let's have a look at another problem. Here we want to find the positive odd integers less than 16. First of all, less than 16, so it's 15, has to be odd. It has to be positive, and there you go. Then we want to find the whole numbers between 5 and 10. Whole numbers are simply numbers like 1, 2, 3, but in this case you start at 6 and you have to finish at 9. Non-positive, that's a difficult term. Non-positive, that means it's negative, but it can also be 0. And it has to be even, and it has to be greater than -10. Quite a difficult problem, that last one. It's -8, -6, -4, -2, and 0. I've got one more problem on types of numbers, and that's actually quite difficult, but rather interesting. Let's have a look. That problem says, show that 0.27 recurring is rational. So that's 0.27272727. That's what that little stroke means. Now, we know that, and now we can actually multiply that number by 100, and the 27 goes in front of the decimal point, so I get 27.272727. Then I do a subtraction, and if I subtract one of those from 100 of those, I get 99 of those. And you'll find that all this yellow, that those decimal places after the decimal point will disappear, and I end up with 99. Lots of 0.27 recurring is actually equal to 27. Then I can rearrange that to show that 0.27 recurring is 27 on 99. So it's a rational number.